Today we have Michael. He just gave a keynote speech at Aging Code Summit. First of all, personally, I'm really inspired by his pivoting.
Thanks.
Yeah, so I wanted to ask that question first. So after leading the biotech division at EPCG over 25 years, you made a powerful move last year by joining Life Biosciences, choosing the dedication your next chapter to longevity. I found that incredibly inspiring. So, what sparked such a major shift for you?
Yeah. Okay. Great question. Thanks for having me on. So I did a project for a client, and we had to scan the landscape of longevity science. Was there anything real? Should they be investing in it? And that led to some action on their part. But it gave me a chance to really scan the technology, and I just became convinced that there was a really great bet, particularly on the technology of partial epigenetic reprogramming, which is Life Bio's technology. And I had to be a part of it. I couldn't kind of stay on the sidelines, so I voted with my feet and joined the company.
Oh, that's amazing, because you already understood whole the landscape of that section, and also you have, without doubt, you have really good strategical mindset. So as a founder in longevity area, your pivoting also means a lot to me. So yeah, it was so inspiring.
Oh, thanks.
Can you give a 1-minute introduction of your work?
Sure. Partial epigenetic reprogramming seeks to tap into the same biology that makes babies young from our old cells, right? So adults can have babies, which is kind of, the more you think about it, profound, more and more profound, right? Somehow there's biology built within us that can de-age cells.
Yeah.
And Shinya Yamanaka won the Nobel Prize in 2012 for showing that you could do that and make what's called induced pluripotent stem cells, taking cells all the way back.
Wow.
People focus on the fact that there was pluripotent, that they could become anything, but they were also completely de-aged. So when you take a cell and you then grow a clone from it, that clone is born as a baby, even though it came from an adult cell. Now, you don't want to take cells in your body all the way back to pluripotency, because they need to function the way they are, right? Nerve cells have to stay nerve cells, muscle cells, and so on. But the insight that was on the cover of Nature in 2020 out of the Sinclair lab at Harvard was that if you treated with just 3 of the 4 Yamanaka factors, you could take cells partway back, and you could change what's called the methylation pattern in a way that was consistent with a younger cell. And you then saw but at the cellular level, at the tissue level, and at the organism level, that there was a rejuvenation effect. So very cool. There's a lot of work now to bring that insight into the real world and make it a therapy for people. But we've gone from mice, where the original work was done in, to now we've demonstrated in non-human primates, and we're eager to enter the clinic, anticipated beginning of next year.
Yeah, I'm eager as well. Yes. My next question is, what do you think aging will look like in 5 years?
I believe, and I think Life Bio believes very strongly in, that efficacy and safety have to be proven in a controlled way, consistent with how regulators have looked at this historically, FDA, EMA, other regulatory agencies. I think that's important so that people can trust what they're getting, that they know that the claims are real.
Yeah.
It's been demonstrated in a controlled, randomized trial. That does take time. So that means that therapies that are entering clinic today, maybe in 5 years is roughly when they would hit the market. So I think what we'll see in 5 years is the things that are just now entering clinic will actually become available to patients around that time. That might include our therapy if we're successful and timing all works out, which would be, it's a treatment for 2 particular kinds of optic neuropathies. Blindnesses. One's called glaucoma, which many people have heard of, and the other is called NION, non-arteritic interior ischemic optic neuropathy. It's a long word, but essentially it's a stroke that damages the optic nerve. We hope to be able to bring benefit to those patients. There are lots of other therapies, obviously, from other companies that are using similar pathways that I hope will also be able to bring benefit to patients in that time frame.
Okay, good luck. Where do you see the biggest challenge in the aging science right now?
I think attention is the biggest thing. Where there's a will, where there's focus, there's a way. I think a lot of just the general public doesn't realize the quality of the science that's available now. That means the level of funding that comes from public agencies as well as private is probably below what it should be. Less than 1% of the NIH budget goes to aging research,
really
right?
Yes.
And you can argue exactly how high it should be, but given aging is the root of most diseases that afflict us, probably more than 1%. And of course, that means company, foundation, all the things that are downstream of that is also a lot lower than it would be. There's only a couple hundred companies in longevity science on the biopharma side versus thousands, outside it. And I'd like to see those ratios come more into equilibrium. And I think that starts with people becoming aware of just how valuable this could be to all of our health span and lifespan.
Yes, with our EON.HEALTH is doing that kind of work. So we developed the product solution for consumers to expand the awareness of the longevity science and the improvement. Yes. What's one thing you wish more people understood about longevity?
So how close we are to some of the big breakthroughs. I think the thing that people find conceptually difficult is this idea that we can de-age cells. But we've already proven it in the context of induced pluripotent stem cells. When you make a stem cell, a clone, it's born as a baby. So we already can take an old cell, and we've now shown it in cells even from people 100 years old, and de-age them all the way back. Now, we can't quite do that inside the body yet, which is the sort of what we're aiming for next. But we're so close technically that with just a little bit of push, I think we're going to see amazing changes in the near future.
Oh, yeah, so promising, I believe. Thank you for today's interview.
Thank you.
Yes.
Oh, great.
Yes.